Hi, this is Shira, and this is my bridge documentary for Mr. Maloney's 7th period Honors Tech class. The core technologies as defined in Maryland are the major content elements used to create technology devices and systems. The first one we use in this project is materials technology. This is a technology of producing, altering, and combining materials. We used wood in this project in order to create bridges with high efficiency at a low price. The second technology we used in this is structural technology. This is the technology of putting parts and materials together to create supports, containers, shelters, connectors, and functional shapes. We had to create bridges in order to be able to carry as large a weight as possible. This required us to take into account forces that can harm bridges as well as what we can do to keep these bridges resilient to these forces. The last core technology we used in this project is thermal technology. This is defined as the technology of producing, storing, controlling, transmitting, and getting work from heat. This applied when we used hot glue in order to create sturdy bridges. The first type of bridge shown is an arched bridge. These are very old designs. The arch lets the weight be carried out to the sides through curving paths. Abutments are used at the points that the arch meets the ground. The second type of bridge shown is the suspension bridge. The cables are supported from towers. Suspension bridges are usually used for spanning long distances. Beam bridges are the oldest type of bridges in which a tree plank or girder system is supported between two piers of ground. Lastly, we have cantilever bridges. Cantilever beam bridges are built so that the middle beam is supported by the two outside beams. There are three useful types of trusses: diagonal trusses, Warren trusses, and Pratt trusses. Usually vertical trusses would not be advised because triangles make bridges much sturdier. There are three types of roadways that a bridge can have. The first is a deck truss. This is a type of bridge on which the road deck lies above the structural parts. The supporting beams of the truss structure are arranged in triangular patterns to distribute loads and ensure the bridge stays stable. The second type of roadway shown is a pony truss. This is a through bridge truss having its deck between the top and bottom chords and having no top lateral bracing. The third and last type of roadway is a through truss. The through truss bridge consists of two side trusses connected across the top and bottom. There are four forces that can affect bridges. The first is tensile stress. This is when forces try to stretch material and pull it apart. The second is compression stress. This is when forces try to push or squeeze material together. The third is shear stress. This is when forces try to make materials tear and slide by each other. And lastly, there's torsion stress. This is when forces try and twist and bend materials. To design these bridges, we had to first make sure they were structurally sound. We designed them on the computer to see if they would be able to resist the forces of tensile stress, compression, shear, and torsion. We then built our designs on Vectorworks and printed them out. We began to construct our bridge by placing wood on top of our sketches. We created the first truss and then the second and attached them at the sides and bottom. Lastly, we placed wood on top of the bridge, and we placed small pieces of wood over the joints in order to increase stability. Here my bridge is shown with all pieces intact. The bridge was attached to a weight in which it was pulled upon until the bridge broke. You can watch this video to see how my bridge broke. Ready whenever you are. My bridge broke because there was not enough support at the bottom of the bridge.